So for task 1, we had to include the correct normals for all of our existing pre-made models, which wasn't too bad, but just kind of took a minute to wire into the constructor methods. For shapes like the cubes and the sphere, we already calculate the normals, or they're sort of given to us. And on the cube, the orientation of the faces will always align to one specific axis. And with the sphere, we're already projecting outward from the center to build the ring of vertices. So we can also just store those values as a computed normal for each vertice. And then for the pyramid, though, it's a little different because the triangular faces are slanted there, and there's no given normal for each face. So we have to compute we have to get two vectors from the 3 points and then do the cross product of them and normalize that in order to find the normal and then feed that in. And then for the terrain model, down here we set up a method to walk through each vertex in the terrain, but to ignore the sides, so we only focus on the inside vertices. And then from here we approximate the neighbors from left, right, down, and up of the neighboring vertices, and then we average those to get the normal for the vertice. And then flat plane, similarly to the cubes, also just has a already axis aligned set of normals. So for task 2, we had to create a new shader class that would allow us to apply a texture that incorporates lighting. So I made a new shader texture light class that sort of leveraged the setup from shader color light, but the main difference is that we now squeeze in a text chord assignment into the input layout to correspond to the texture we want to use, and then we also have to set up the sampler to process the texture. And then with the new shader texture light, I made a new texture light.hlsl, which is similar to the shader color, or the color light HLSL, sorry. And then down here, we blend the computed light values against the diffuse text sample, and then we return that. And then for task 3, I created a new shader color multi-light class, which also extends off of the shader color light class, but instead of sending the data once, or the light data once, we instead set a const of the max amount of lights that we want for point and spot. And then we declare that down here. And then from here, we also just build a list of the lights and the data that we want. So we just kind of add them and make sure that we don't exceed our maximum slot count. And then within the HLSL file, it's kind of similar to, which one? colorlight.hlsl, but instead of computing the light values once and then returning it, we run through and loop through the number of lights that we have set up, and then we return that value. And then putting this all together, we have a cube to use, skybox, sphere, and then terrain texture and height map. And then running the scene, we can see that the height map still works properly, and then the texture has lighting, and the sphere is aware of the second light, but I don't think it's shining on it directly, so it isn't showing up. And then this other light is here.